All right, welcome to part three and the final part of this introduction to Matlab course. Today's session is going to be focusing on data analysis in Matlab or data processing, and then we're also going to do a little bit of linear algebra. So something for everyone. I think a lot of you will be interested in using Matlab for data processing, and we'll see some of the things that MATLAB's really good at and some of the stuff that MATLAB struggles with. But MATLAB was really invented to do linear algebra. That's what the MAT in MATLAB stands for, is Matrix. Matrix Laboratory is its sort of full title. So I'm going to show you how you can solve linear algebra problems in MATLAB as well. And that's going to be in the second half. The first part, as I say, is mostly data analysis. And I'm going to set you a bit of a large challenge, which could take you quite a bit of time. I'm quite happy for you to spend half an hour, even an hour, going through this exercise. If this were face-to-face, I'd be happy to give the class that amount of time. So we're going to download a data file, and then I'm going to ask you to try and do some stuff with it. Starting off, as I say here, there are lots of ways of saving and reading data in MATLAB. A good question to ask is, do I want to open this saved data in another program? And if you want to open the saved data in another program, then you want to make sure that any data you save from Matlab, so this is saving data from Matlab, should be in a nice file format that other programs can read. Text files, CSV files, that's comma separated value file, stuff like that. Matlab is also able to save things like .mat files you might have come across. These are essentially sort of session files for Matlab, so Matlab can reopen all of these things and start wherever you were. But for cross-compatibility, not the way to go. So let's go ahead and import a data file, which maybe has come from somewhere else. Maybe you've downloaded it from the internet, or maybe it comes from a piece of equipment that you've been running. Here it's going to be a CSV file full of exchange rate data. All right, so we're going to have to go ahead and download it, and you're going to download it from this GitHub repository. So again, the address github.com/pecnet/course intro to MATLAB, where we've been in all of the sessions. If you go up to the top of the repo, you can go ahead and you see where there's this green clone or download button. You can click it and download everything as a zip file. If you download everything as a zip file, then obviously this will look slightly different depending on which browser you're in. I want you to go ahead and save the zip file. So go ahead, save the zip file, and then I want you to go ahead and open up the zip file and extract it. It doesn't really matter where you extract it to. The important bit is that when you extract it from inside the examples folder, I want you to copy the exchange rates.csv file. Okay, so again, that's in the downloaded zip. You need to extract the zip. Right, to extract it somewhere, doesn't matter where. Go inside the examples folder, copy and paste exchange rates.csv. And I want you to copy and paste it, so we can go ahead and copy it, and I want you to paste it into the folder where you've been saving all of your MATLAB files. All right, so wherever your MATLAB files are, I want you to go ahead and to paste it in here. So I've pasted it in here. There it is, exchange_rates.csv. So now it will be there and ready to go. So no, it will be ready to go. That's what we want. If you see this, then we're good. At this point, we can go over to Matlab, and you should be able to see, if you have in your current folder window, a list of all the files. Now, this might not be the case for you, but hopefully it will be. It doesn't really matter if you don't see this. There is exchange rates.csv here on the left-hand side. If that's the case, then we'll be ready to go. But I'm going to give you a moment now to do that, and then we will take a look at what this folder, also what this file looks like, and we'll go about importing it into Matlab. So I'll give you some time to do that now. All right, so hopefully you've got the exchange_rates.csv file loaded up. I'm going to have a look at what this file looks like outside of Matlab first. So I'm going to go ahead and open this up. It's a CSV file, so we can go ahead and open it up in Excel, for example. If we go ahead and open it up in Excel, then you will be able to see what it looks like. Here's what it looks like if you open it up in Excel. So it is it's a spreadsheet. Along the top, we have a list of different currencies, so you can pick your favorite along here. And then down the left, we've got a bunch of numbers. These numbers correspond to days in a particular year, with January the 1st being 1, going all the way down to the end of the year. I think it goes down to 365. Notice that not every day is listed. Foreign exchange markets don't open on every day of the year. They don't open at weekends, and they don't open on big holidays. So it goes all the way down to 365. And this table is therefore a list of exchange rates. It's exchange rates against the US dollar. If you take a look at the USD column, then everything is a bunch of ones. Well, that makes sense. The US dollar is always 1 against the dollar. This is the exchange rate against the dollar in these days of a particular year. All right, so this is exchange rate data from a particular year in relatively recent history. This is what it looks like if you open it up in Excel, but it's a CSV file, so Excel has added the formatting itself. If instead you opened it up in a text editor, something like TextEdit or Notepad or Atom, as I've done here, then you can see what this file actually looks like. It's just a bunch of numbers separated by commas. That's why it's a comma-separated values file, CSV file. There are all the commas, and you can see that the data's all there, but it's poorly formatted. But this is a nice format for other programs like Matlab to be able to import. It's simple. The commas separate everything. So now we should be able to go ahead and import this file. We're going to create a new script. Let's go ahead and create a new script. So new window here. Let's save it as exchange rate data. Let's call it that. Exchange rate data. All right. Now let's read in the data. Data equals, so I mean data is just something I've picked here, but data equals, and then we're going to use the command CSV read, so that's the command for reading in CSV files, and then the name of the file, exchange rates with the underscore .csv. Okay, I haven't put the closing bracket in yet because I'm not finished. And then there's something specific that we have to add to this command. If you remember, the top row of the data is a list of currency titles, right? It's text. MATLAB's CSV read function can't input text. Like, it doesn't understand text, it only understands numbers. So you want it to ignore the top row of the data set. So you want to get it to say ignore one row at the top. So to get it to ignore one row, you have to add CSV read, so the name, and then comma, the number of rows to ignore, and then the number of columns to ignore. We don't want it to ignore any columns, so that's the format there. And indeed, if you click on CSV read and hit F1, give it a while for the help to load up. It always shows you the previous help until the new one shows up. It will tell you what the syntax is. I think R1 and C1 is what it calls it. Here we go. It's not recommended Okay, you can look at this. You can look at this yourself. Here you go. R1 and C1, where R1 C1. This reads data from the file starting at row offset R1 and column offset C1. Right, so that tells you how many rows and how many columns to ignore. Okay, if you go ahead and run this, well, nothing's going to happen, right? Because you've got the semicolon here, or at least it's not going to look like anything's going to happen. But if you go down to the command window and ask for data, so you've run this file, so it's done something. So it's assigned data to be something. You can see down in the workspace that data is now a matrix 257 by 35, and it's full of doubles, which are decimals. If we go ahead down here and ask for data, we should be able to see the data when it's printed out. So we ask for data, press enter, and we get a lot of numbers. All right. Now, don't worry that these numbers look a lot smaller than the numbers in the actual data. Matlab has a habit when it has numbers of different sizes. It likes to try and write them all in scientific form, with everything having the same exponent. So you might be able to see if you scroll to the top that there's a 10 to the 4 times everything down here. Don't worry, that's just how it likes to format it. So all the data is in there as a matrix. And so now I'm going to ask you some questions about this data and get you to do some things. And all you have to remember is that data is a matrix. And I'm just going to be asking you to take columns out of this matrix and plot them against other columns of this matrix. That's it. So here are the questions, and indeed these are on the GitHub. So let me scroll back down to where we were. Here we go. So I want you to plot the pounds per dollar price, that's the 12th column, against the day of the year. That's the first column. That's the first thing I want you to do. Right, so you're going to have to extract this, and you're going to have to extract this. So that's just selecting columns of data. And then you just have to plot one against the other. So let X be one of them, Y be one of them, and then you just plot X, Y. And then on the same graph, I want you to plot euros per dollar against the day of the year. And then on a new graph, I want you to plot euros per pound. Okay, so on a new graph, so that can be a new script, that's fine. Plot the euros per pound price. So for this, you're going to have to do some division of columns. Now, remember in the first session, I promised that that I think at least one of you will forget that there's a subtlety involving element-wise division of doing columns divided by other columns. So remember that when you come to try to do this here. If you get something that's not quite what you expect, it might be because you've forgotten that doing division of one column by another column or one vector by another vector. If you want element-wise, then you have to use a subtly different command from just division. So I want you to plot this. And then here's just a bit of a current affairs question. By taking a look at this, maybe you'll be able to guess which year this data is from. This is just a bit of a joke question, so don't worry if you can't tell, but you might be able to tell by the shape of the data. Here's a question that you all should be able to answer. What was the minimum number of euros you could buy with £1 that year? All right, so that should be able to tell by looking at the graph, and maybe you can use a function to find out what's the minimum value that year. And then also, on which day of the year was that the case? Okay, now that is a harder question, but if you look at min in the help files, you will see how to extract that information as well. Because min, that's the minimum function, can output more than one piece of information. But if you look up min in the help files, you will see what the syntax is to be able to find out which day of the year that's the case. All right, so that's a bit of a challenge, and I say this could take you half an hour. It could even take you an hour. That's fine. Take as long as you want. Enjoy it. If you have questions, indeed, I'm on Teams, so you can ask questions. and yeah, have a go. Once you are happy to continue, then come back to the video. All right, so I hope you enjoyed that. I'm going to show you how I would do these things now. So let's get Matlab back up. So we've imported the data file. The first question was to plot the pounds per dollar price against the day of the year. So the pounds per dollar price was the 12th column, so that's the 12th column, so that's all of the rows and the 12th column. And then the day of the year is all of the rows and the first column. All right, and I just want to plot day against, or rather the other way around, I want day on the x-axis and pounds per dollar on the y-axis. All right, let's run that. What do we get? Okay, so it's making the graph. Here's the graph. Okay, so we see something, bit of a jump here. The numbers go along the x-axis from 0 up to sort of 365. That seems good. And the numbers seem about right. Yep. Okay, nice. Then on the same graph, I also want euros per dollar. So that's that EUR USD. That's the 11th column. So I also want to plot day versus, I need to say it the other way around, day on the x-axis and euros per dollar on the other axis. But remember that if I want to make the graph sticky, I have to use hold on. So let's run that. There we are. All right, so that's the second one up here. That's the euros per dollar in the red color. And then on a new graph, I want to plot euros per pound. All right, so let's first work out what that is. Euros per pound. So that's the euros per dollar divided by, okay, so I'm going to do this wrong and then I'm going to correct it, divided by pounds per dollar, right? So that should be euros per pound. But if you did this, right, and if you weren't careful, so there's something wrong here, but if you did this, you'll get a shape which you might recognize. Let me show you what that is now. I'm going to comment out these because we've seen what they look like. Let's plot day and EUR GBP. If you did this, you would have got a graph that looks like this. A lot of white space and a sort of a yellow line along the top. And that's because your EUR GBP, because you've done one vector divided by another vector, and MATLAB has helpfully thought you wanted to do some strange matrix calculation, and you've ended up with a giant matrix of data, and it's tried to plot every column in your matrix, which is all very strange. What, of course, you want is element-wise division, so you want the dot, and if you put the dot there, dot slash, then you get euros per pound. So here's euros per pound over time. All right. Oh, the question was, can you guess which year this data is from? And I thought you might be able to tell that the pound was doing sort of doing its own thing, and then there's this big drop in the middle of the year, which tells you, and it continues to drop down. This is 2016, this data. I daren't even look what the pound's doing at the moment. But there we go. That was a bit of current affairs. Oh, the question was, what was the minimum number of euros you could buy with a pound in that year? Let's bring that data back. So the minimum number of euros you could buy was sort of down here. Indeed, if you hover over, you might be able to tell. So on day 291, you can see it there. You could buy €1 and 10 cents for the pound. Can we get that out of the code? All right, so that's on day 291. I'm going to write that down actually. 291, and you can get €1 and 10 cents. Let's see whether we can get that out of the data. So let's have it display the minimum of EUR GBP. Don't need the semicolon. Press run. Okay, there it is. €1.10. That's the minimum down here. This is still popped up, but we don't really need it for now. But then the question was, on which day of the year was that the case? Right, so we know by looking that it was day 291, but can we get this out from the min function? Well, the answer is yes. Let's take a look at the help for the min function. And you can see that there's this mi version, which at the moment is unexplained, but have a look. Mi also returns the index that corresponds to the minimum value of A. All right, so if you ask for just min, so here we go. So min euros equals min EUR GBP, and if we ask it just to display min euros, then we're just going to get the same as we did last time. I'm not going to ask to plot it again. There it is, 1.10. But if we ask for min euros and the index that corresponds to this minimum, well, let's see if we ask it to display the index as well, what we get. All right, so we now have index 204. So this isn't the day, right? Because remember, the day doesn't start counting at 1. I think it starts counting at 4. This is the index, so it's the row number. So if we want the day that corresponds to this, we need to ask for the day in the 204th row. And that's easy enough to ask for, right? Because that's, if we've called the first column day, like I've done here, then that's just day index. There it is, 291, like we saw from the graph. All right, so that's how I would do it. In a moment, we're going to go and do some more complex, well, okay. Okay, so that's how I would do it. In a moment, we're going to go and save this data, but if you'd like to take a short break, now's a good time to do it. All right, so let's go ahead and now save some of this data. Let's create a new matrix, data pounds, which contains the exchange rates of these currencies against the pound rather than against the dollar. So that's the instruction on the GitHub down here. So create another data matrix, data pounds. So everything is going to be against the pound instead of against the dollar. Let's go and do that. All right, so I'm going to delete these, but I'm going to keep the top as we have it so far. So data pounds is going to be our normal data matrix, but I want to divide everything through by pounds per dollar. So now the whole matrix is going to be divided through by pounds per dollar. And in fact, I don't need anything apart from this, I think. So everything in the matrix is going to be divided by pounds per dollar. So now everything is going to be against pounds, right? Okay, if you think you've spotted something wrong, you're probably right. But let's stick with it for now and then see what you think. Let's go ahead and save this. So let's save it by using CSV write. Let's call it exchange rates pounds.csv. And the file that we're going to save is data pounds. And that's it. So let's run this. we might see on the left-hand side exchange rates pounds.csv appearing. Aha. All right. I'm going to give you a minute to do this now, and then I want you to have a look at the CSV file in Excel and tell me what I've done wrong. All right, so let's take a look at what it looks like in Excel. I'm going to open it up and bring it over. There it is. Open up in Excel. There we go. Now let's have a look. Okay, so here it is. The titles are missing. I'm not going to tell you how to fix that, mostly because it's pretty difficult, and it's one of the problems with doing data processing in Matlab. But you can see that column L, which originally corresponded to pounds, is all 1, so that's good. This was the euros column, so now everything's against the pound, and these numbers look sort of familiar, so that's good. But of course, you might be able to spot the real problem, which is that the first column, which is the days, they've all been divided by the pounds, by the dollars per pound, which is very silly. So we need to make sure that we don't do that. So let's try to go ahead and fix that. And we can fix it by just not changing the first column. So how about we let data pounds at the beginning just be just a copy of the original data file, and then only go ahead and change columns 2 to the end. So I want all of the rows, but only columns 2 to the end, and I want those to be equal to data, but again, I just copied and pasted. I want all of the rows and 2 to the end divided by this. So think about the logic for this. I'm starting by letting data pounds be a complete copy of the original data set. So that means everything is the same, including the first column. And then I'm only editing the second column all the way to the end. That's what I'm doing here. All right, so same command as before, but only on these columns. So now I think if we try to go and run this, let's open up the file in Excel. Aha, and our numbers are back, which is good, and still everything is against the pound, which is what we wanted. Nice. Okay, so I said that getting the title bar in is awkward, and in fact it is. One of the problems with using Matlab for data processing is that it doesn't particularly handle non-numeric data well. Newer versions are better. If you had a look earlier when we typed in CSV read and I went to the help file, it told you that CSV read isn't recommended. The problem is if you're using older versions of Matlab, then it's the only option that you have. Newer versions have better tools for this, but at least on some of the college computers, they're still running 2016 2016B, and you don't always have the choice. So in that respect, other options instead of Matlab, like pandas with Python, for example, are better data processing tools. Matlab has difficulty, as I said, handling things like text. It has difficulty handling things like dates. You'll realize that, of course, I didn't give you proper dates in that first column. That wasn't because I was trying to make it into a puzzle. It's just because Matlab, you can get it to handle dates, but the code is quite ugly. That doesn't mean it's not possible. You can just copy and paste something from the internet that allows you to understand it. But it's difficult for a tutorial, which is why I haven't bothered. So, yeah, your mileage may vary, I find, with data processing in Matlab, but hopefully that was a little introduction to how that might go. The only thing left now then is for us to have a look at the linear algebra component of Matlab. So again, if you'd like to take a break, now's a good time to do just that. All right, so I promised to talk a little bit about linear algebra before we finish the Matlab course, and so this is the final bit of part 3. Linear algebra exists to solve these sorts of problems here when you have a set of simultaneous equations. If you were having to try and solve these for x, for y, and for z, if you weren't able to use matrices in linear algebra, you would, I assume, maybe rearrange this bottom equation to get an expression for x. You'd maybe put it into here, and then you'd keep solving until you eventually got answers for all of them. But that process is pretty laborious. And in fact, there are easier algorithms to be able to solve these sorts of problems. Matlab exists to make writing linear algebra problems like this and solving them as easy as possible. Remember that the way that you solve this with matrices is that you notice, because you have x, y's, and z's, you can write this whole system as a matrix where you pick out the coefficients times by a vector of x, y, and z equals this on the right hand side. So I'm going to do just that. So if I pick up the coefficients, so that's 1, 2, and 3 down the left hand side, and then picking up the coefficients of y, I've got 0, 1, and 4, and then the coefficients of z, I've got 5, 6, and 0. Alright, so that's our matrix. And then you can multiply that by the vector x, y, and z, and we say that that is equal to what's already on the right hand side, which is -1, 0, and 1. And if we want, we can label these. We can call this matrix over here capital A. We can call this vector capital X, and we can call this vector over here capital B. So we have A times X equals B. And then if we want to solve for X, then, well, it looks like, when we want this, we just have to divide through by A, right? So we just have to say, okay, well, that's fine. Then rearranging, we have that X is the inverse of A, because we can't divide by matrices. It's the inverse of A multiplied by B. So the question remains then, how do you find the inverse of A? And how do you multiply it by B? So remember that these weird rules about multiplying matrices together and multiplying matrices by vectors exist so that this sort of calculation does indeed represent this. You might remember that in order to make this top line and this vector turn into this top line here, you have to do 1 times x plus 0 times y plus 5 times z. That's the top line. And then for the middle line here, you've got 2 times x plus 1 times y times 6 times z. That's this line here. And so these weird rules about multiplication is why you have problems with with multiplying matrices or vectors together, and why dot/slash exists to do element-wise. So if we have then x equals A inverse times B, the question is, how do we calculate A inverse? And do we in fact even have to calculate A inverse? Matlab has the answers, and I'm going to show you how to do that in Matlab now. Alright, so let's go ahead and try and solve this system in Matlab. I'm going to start by creating a new script. Let's call it linear algebra. I can spell it .m. And then if you remember, or if you flick back to the video a few moments ago, the equation we're trying to solve is ax equals b, although it's more conventional to use little x and little b. So I'm going to continue to do that now, but remember that A is our whole matrix. X, even though it's little x here, is our vector x, y, z, and then B is the right-hand side, that was -1, 0, and 1. So let's go ahead and write down what the matrix A was. That was 1, 0, 5 along the top, 2, 1, 6, 3, 4, and 0. And then B on the right hand side was minus 1, 0, and 1, which we can put in like that. All right, but now we want to solve it, right? So I said that by rearranging, we could say that x is equal to the inverse of a, which in Matlab is inv of a, multiplied by b. And now this is proper matrix multiplication, right? This is absolutely what we want to do. So this should work, and let's get it to display x. Let's run it. So what we're hoping to see is an output for x, which will be three things, and that'll be values of x, y, and z, which will make the equation work. Let's check it out. 19 minus 14 and minus 4. All right. And if you go back to the equation we were trying to solve, then you will see that letting x be 19, letting y be minus 14, letting z be minus 4 would make the equation work out.
And okay, if you don't believe me, let's do it here very quickly. We had that x equals 19, y was minus 14, z was minus 4. So the top line we have x, that's 19, plus 5z is now minus 20, which does indeed equal minus 1. 2x plus y plus 3z, so that's now 2x, that's 38, plus y, so that's minus 14, plus 6z, 6 4s are 24, that does indeed equal 0. And then on the bottom row, what do we have? 3 19s are 57, and then plus 4y, 14 times 4, 28, 56, which does indeed give us 1.
But can you see that there's a red underline here? All right, so it's trying to tell us something, and I'll tell you what's going on here. You don't, in order to solve this equation, even though you're doing A inverse times B, you don't need to calculate the inverse of A in order to be able to solve it. Now you might know this by when you try to solve these sorts of equations yourself. But it isn't necessary to calculate the inverse of A in order to multiply it by B. There are processes that allow you to take A and take B and to work out the inverse of A multiplied by B without calculating this. Because working out, and this is a technical point, but if you're interested in computational linear algebra, and why wouldn't you be, there's an excellent introduction book by Nick Trevethan. Calculating the inverse of A is an order n cubed operation. So if your matrix is n by n, then the complexity of calculating the inverse of it is n cubed. So that's pretty high as far as complexity goes. Whereas calculating the inverse of A times B, if A is again n by n, can be as low as n to the 2.2, 2.3 with the right algorithm. So that's a significant time saving. There's a general rule in this stuff, which is never calculate the inverse of a matrix unless you absolutely have to. And so the correct solution is instead not to use this, but to use MATLAB's most famous function. And I had to show you this because this is why MATLAB exists. The most famous function in MATLAB. You absolutely have to see it, and it is to solve this sort of system here. Don't write this. I'm going to comment it out. Instead, write x equals a backslash b. Oh, right, that's backslash. So if you're on a Windows computer or you've got a standard ISO keyboard in the UK, that's to the left of the Z key. If you're on a Mac, it's to the left of the Enter key. Good luck if you're using a different type of keyboard, but I'm sure you'll find it. This here is what you want. And this backslash is so famous and actually super powerful. It looks at all sorts of things to do with A. It looks at the size of A. It looks at the structure of A. Like, are there lots of zeros? Is it sparse? Is it dense? There's a whole checklist of things that it does before calculating it so that it picks the fastest possible algorithm to solve this system for you. And for 3 by 3, I know it seems trivial, but I do stuff with matrices that are, thousands, tens of thousands long. And this can make, the difference between a calculation taking days and taking hours, right? It's a significant saving. And it's one of the reasons that Matlab is, is as used as much as it is. It's very, very clever. Okay, so I'm going to give you some time now to type this in, convince yourself that it works. I'm not going to show you the output of this just yet, but you'll be able to try it yourself. And then on the GitHub page, I've given you a couple of things to try. I've asked you to solve this set of simultaneous equations. So this is going to be a 2 by 2 system. You have to pick out the matrix here. So you have to pick out the coefficients from here and here. So you write down the little matrix equation just like I did, and then solve it. So you get a solution for x and y. And then I have this other problem here where I've given you a matrix A, vector B, and I want you to, again, try and solve AX equals B. Let me know how you get on. And I've added a follow-up question here. See how you get on. If you run into problems, I'm going to ask you to find what's known as the determinant of A. So this is a mathematical property of a matrix that tells you something important about it. And if you don't remember it, that's fine. You'll work it out, and you might have to Google to find the function that gives you the determinant of the matrix. Have a go at these two things. So a slightly more mathematical problem just to finish us off, and then come back to the video, and I'll show you how I did it. All right. So let's firstly just show that this famous backslash works. Remember, we had the backslash here. Let's press run. Aha, there we go. Nice, good stuff. The second thing was to solve the system of equations that I've written down here. I'm just going to copy and paste these just above here so that we can see what the matrix should be. All right, so the matrix A, picking out the coefficients. So that's a coefficient of 1 and 1 here on the top. And then the second equation has a coefficients -1 here and 3 here. And then the vector down the right-hand side is 2 first and 3 second. Don't worry if you're out of practice doing this sort of stuff. I think this is a nice thing to finish with, and it's a nice thing to show you. And this is the power of Matlab. All right, let's give this a run. Let's see what we get, x, and this will give us, therefore, the values of x and y in these equations, which will give us a solution. Let's press run. We have 3/4 and 5/4, 1.25. Nice, all right. And then finally, I gave you a new value of A. Let A be this, B remains the same. So A is now this. Oh, sorry, I say B remains the same. B is what it was originally. That is to say it was -1, 0, 1, and this is not true anymore. Okay, solve AX equals B, so we try and do the same thing. We press run. And, oh, what's this? Matrix is close to singular or badly scaled. Results may be inaccurate. R cond equals this basically 0 number here. It's 10 to the -18. And the solution is, what, 10 to the 15 times this. Sounds like nonsense. And indeed, what this is telling you is that something is wrong. There is something specifically wrong, which I hinted at in the question. I asked you to find the determinant of A. Now, the determinant of A, if you Googled it, you will have found that the command to find that is det A. The determinant is a sort of measure of the matrix A. It's a measure of, if you multiply a vector by this matrix, how much are you going to scale the vector by? It's that sort of idea. Let's have a look at what the determinant of A is. So I've popped it in there, so let's run it again. So now we're going to display, the determinant of A is basically 0. And indeed, if you work it out longhand, it is indeed 0. And if the determinant is 0, it means you can't invert the matrix. It means your solution, or it means your equation, has no unique solution. All right, so there are multiple choices. Indeed, you might even be able to go and find some of them. There are normally an infinite amount of values of x, y, and z that solve this equation. And because there isn't a unique solution, Matlab isn't able to find it. The linear algebra essentially breaks down here. Another way of saying that is that one of your equations says the same as another one of your equations. All right. So that concludes what I wanted to show you with linear algebra. If you want to play with linear algebra a little bit more, there's a bunch of extra stuff following down. In fact, I'm going to show you what this extra stuff is now. I'm not going to go through this stuff, but it's here in case you're interested. There's a little bit on matrix arithmetic, something about sizes, more stuff to play with. If you're interested in eigenvalues and eigenvectors, then this is how you work it out. If you like 3D plotting, there's a little example down here of how to do that. And if you want to play around with strings, then there's some of that down here too. I've added some built-in functions you might want to play. And then here's some extra information about some more advanced MATLAB techniques here and here. If you fancy some extra programming challenges and you have some time on your hands, then I've added a few extra little challenges down here which can keep you occupied. Feel free to have a go at them in your own time. And then the final thing for the entire course is to ask you to fill out the feedback form from the graduate school. So if you follow the link from the GitHub page and the feedback form, this link will take you to a form to fill out where you have to select this course from the drop-down. There should be an option for this remote version of the course. I think it would be really, really valuable for us to get feedback on doing courses this way. Anything we can do to try and improve it. Obviously, it's new to a lot of us, so that would be super valuable. Okay, well, I'm going to still be on Microsoft Teams for the rest of the session. Happy to answer any questions that you have. And otherwise, thank you very much for participating. We have another bunch of courses still running. I'm not sure what the queue is like to get on them at the moment, but at the moment, I think there's probably a good chance if you're interested in doing them. We have courses in other languages, courses in Python, in data processing in Python. I mean, I can tell you that one is guaranteed to be a hoot. I hear the lecture is extremely engaging, even in online form. And we have more stuff as well. So go ahead, enjoy some of those. And thank you very much for taking part in this Introduction to MATLAB course. I hope you feel that you've learned something and have a bit more confidence now just to go ahead and try stuff in MATLAB. If you don't know how to do it, don't worry about it. Google it, stick it in, and enjoy using the software. Thank you very much, everybody.